Okay, so the final part of the homework. So let me go to the assignment. Repeat number 2. Using Crank-Nicolson finite differencing for the second derivative, demonstrate that it is stable for arbitrary values of r. So basically what we're going to be doing is we're going to be graphing the same thing, kind of. Well, no, okay. So we have to change the equation around, and so that we can have higher values of r, higher values than 0.5. So let me turn my pen on first. And then we're going to go text mode. We're going to go over here, right? So we are going to first talk about, so repeating kind of number 2. Okay, that did right. So t, then j plus, or to the n plus 1. If I can get a plus sign real quick. Okay, n plus 1, and then we had, I think it was minus tj to the n, and then you have equals to, oh yeah, and this has to be over time, if I'm correct. Yes. Okay, so then you have the alpha value, and then you have, let's see, let's have t, and then over on this side of the equation, we're changing the time, so it's going to be steps of n. Oh, no, not the time. Changing the position, so at the same time of n, right? If I can. Okay, and so then we have j plus 1, because we're taking, it was the average before. So, and then you have over 2, t, and then so the initial position at time n. Going to text mode so I can move my screen over so I can write over here, and then you have plus t, and then so the position before that on the bar, and this is supposed to all be over a change in position, right? And we're doing this in x. So with the Crank-Nicolson, we are actually taking an average to over a larger period of time, actually, so that we can have more stability. So we're gonna actually change, well, not change. So let's, what did I just do? Okay, it's fine. It's fine. So we're gonna put this parenthesis here, and it's there. Okay, so then let's go to text mode, go over here, and we're going to do at a different time. So this is going to be the time after. So it's going to be at n plus 1, right? But it's the same thing. So tj plus 1, and then n plus 1, and then minus 2j, and then n plus 1. And so then let me move my screen over a little bit, and then we have plus temperature at position j minus 1 at second time. Okay, and then we have this, and we put it in the brackets, and we put this over a change in x. And then we also, oh wait, no, over x squared, since I don't want to write another, what is it called? Another fraction. Instead of putting that all over a change in x, we just put a change in x squared. Okay, so since the part I just wrote down on the right side is the, what is it? The position. Okay, so it's not the initial position, but it's the position afterwards, and we're taking an average. Yeah, this first part is going to be negative, so let's put it right here. Oh, that looks like a plus sign. Why did my thing just do that? Okay, so negative. Oh yeah, and then we have to also have this over 2 for the average. And so basically your R value, you go text mode, your R value becomes an R is equal to this over 2 times the change in time over change in x squared. I always am apologizing for that being so ugly. Okay, so basically what we're going to do is gonna kind of move things around again so it's all nice and pretty like last time. So Tj to the n plus 1 is equal to, so then we're gonna have to, the T temperature at position J in, okay, so then we're gonna have plus R because that R is this temperature here, and then this alpha over 2, and then these x squareds on that side, right? So R, and then we're going to multiply this negative on the inside of this thing right here. But I'm going to put it on the other side, so let's see. It says Tj, temperature, position J plus 1, n plus 1, time n plus 1, minus, oops, CDZ, right? Yeah, this is going to be minus 2T temperature J, and then n plus 1 plus temperature at position J minus 1 time n plus 1, and then I'm going to move my screen over, and then we're going to have the stuff with the negative on the left side of the parenthesis right there. So then we're going to have a minus temperature J plus 1 n, yeah, time n. And so that's a negative 2 right there, so we're going to have to say positive 2 at position J at n, and then minus temperature at position J minus 1 at n, right? Okay, so let me zoom out here and figure out what to do next. So that's not all the combining that you can do with this equation. So there is temperature at position J at n plus 1 on this left side of the equal sign, my contact. Okay. And then there's also temperature J at n plus 1, so right here the negative 2. And then let's see, there's this TJN, and then you have that also with the 2 over there. So when you do this, you have to actually multiply that R value on the inside. So let's see. I'm going to move stuff over. So we're going to have negative. Ew, that looked gross. I'm going to zoom in so I can write a little neater. Okay, so we're going to have a negative. Still trying to write neatly. Okay. Third time's the charm, right? At least with my videos. T. Oh, goodness. T. J. And then, here, let's see. It's easier to look on the screen at my OneNote. TJ. I'm lost. No, I'm not. Here's what this means. Okay, so we're going to take everything with the n plus 1 on the left side of the equation, because that's where that one is right there. So, minus, oh, that's what I was lost on. I should have an R there. R, and then so this 2, negative 2 at temperature at position J at n plus 1, right? And so we get a negative temperature at J, N plus 1. And so if you're subtracting, wait a second. Ah, okay, now I see. Okay. At position J plus 1, because you're subtracting on that side. But then you'd be adding. This one. That's a little strange. Oh yeah, it's because it has the R. Okay. I keep forgetting about the R. Let me just draw little arrows so that I don't forget the next time. Okay, so what we're gonna have is, okay, so plus, okay, so TJ, temperature at position J at time N plus 1, right? And then you're gonna have that, and you're also gonna have 1 with the R value, so then you're gonna say, okay, well, I'm gonna add, and then you're gonna say, okay, so 1 plus 2R, I think. Yeah, 1 plus 2R, and then temperature at position J at time N plus 1. Let's go to text mode, move over. And so then we're also going to have, I know that this is the negative temperature, no, negative R times temperature at J, temperature at position J minus 1 at time N plus 1, right? And then you're going to have this equal to, and then it's basically kind of like the same thing on the right side, because you're going to have the stuff that is just the ends, I mean the time end, like the initial time. So you're just going to have the, and it's going to also be multiplied by R, because the R was on the outside of that giant parenthesis. And, negative T to the J. Oh, let me go ahead and put R, because I keep forgetting this. R, J plus 1, N, plus, and then, what is it? 1 minus, or 1 plus? Good question. I'm going to say 1 minus 2R plus, no, not plus. I feel silly. That should be plus. That should be plus, and that means that there's a minus in there, and then you have plus T and then J of position, or temperature at J minus 1 position to the N, and I forgot the, okay, this is going to be a long video. How long is it? 13 minutes? Sheesh. Okay, so temperature, I forgot the T here too. Temperature J at N plus temperature J minus 1 N. Okay. So now what we've got here is this big equation for our bar. Let me exit out of, or kind of move around. Okay, so we're in text mode now. This is for our bar, right? Our bar. Oh, that was a nice. Did you see that? I'm amazing. We got different segments, blah blah blah. So like in amount of in length, this is at 0. This is at 400, I think 400 Kelvin. It said in question 2, and this is at like 350. temperature initial is equal to like 300 Kelvin. And someone's taking a shower now, so I apologize for that noise. Okay, so what we have to do to display this in, co-laboratories, we have to do a banded matrix, right? And so with this, I actually have to move my screen down so I can explain stuff. So we're gonna get this matrix. So we're gonna like, maybe I should do that smaller. Let's see. Oh, never mind. It doesn't have a bottom on it because it's kind of like an infinite thing. So you have to leave the bottom out. Forgot. How wide is this screen? And then we have it equal to this thing over here, right? I'm not gonna put the other side yet because I don't know how long it's gonna be. So with this, you have your unknowns in the middle right here, and you have your knowns right on the right side. So what your unknowns, you're gonna have temperature at J equals to 1 first, and then equals to 2, and then you like boop 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 all the way down. It's infinite, kind of. I mean, it's longer than what I'm gonna do on here because it's a lot of writing and my hand hurts for today. So basically what you're gonna do here is you're gonna plug in those nodes, so R, T, and then so your J is 1, so you're gonna get, if my handwriting was better, I'm gonna go into text mode and zoom in to that area real quick so I can write better. Okay, so you get, why did it do that? What the heck? Okay, it's fine. It's fine. Text mode, go back down to my little matrices. Okay, so T is 2, and this is because of our equation from earlier. So you plug in the J's, and so T equals 2, and then plus 1, and then, no, not plus 1, plus, and then 1 minus 2R, and then T is equal to 1, and then plus, and that's 1 because it's supposed to be J, T to the J, or not T to the J, but TJ, and then this next one is going to be the J minus 1, so that would be like R, T, and then like 0, right? And you kind of just do this with all of them, right? So R, T, and then it's like 3 because it's the next one, plus 1 minus 2R, T2, plus R, T, and then 1, I believe. Yes. And so let me zoom out of this real quick. And so basically, eventually you'd get like some R to the nth, or R to the T in or something, because of how big it would be. Oh, that is really ugly. Okay, I'm erasing, I'm redoing, so R, T, and then N. Right, we don't know right now. So let's move over here, right? And so basically you kind of do like the same thing. This is like a really big matrix. So you get like 1 plus 2R minus R, and you get, yeah, I'm gonna erase that and zoom in like I did the other one so it looks better. Text mode. Okay, so you get like 1 plus 2R minus R, and then you have like these zeros in the matrix, and then you get like negative R. Oh yeah, so yeah, negative R plus 2R, no, 1 2R, 1 plus 2r. Then you have negative r, and then you have zeros, and then you have 0, and so like it's a matrix. Alright, so 1 plus 2r, where this is, and then zeros. I'm really bad at the zeros, I'm sorry. But basically, like, these are all in the same column? Yes, column. Maybe I shouldn't have written that negative r so close to that right there. Oh, I feel silly. Okay. So this is all in the same column. This is in the same, and this is in the same. And this stuff over here doesn't matter. There's like, oh, you can't really see the dots right there. I'm sure you can see it when you full screen. But basically, yeah, you have that. And so what we're gonna do is we're going to go into Colaboratories and program now, sadly. Haha. I'm gonna stop recording. Okay, so I have prepared the Colaboratory with the imports that I need, including the thing to solve banded matrices. Okay, so what we're gonna do first is we're gonna talk about the not positions, but the different segments that we have for our bar. So we're just gonna put something like I don't know. I'm gonna put 1,000 in. NT. I'm just gonna put 10,000. And we'll see how that works out. So for R, we want it to equal something that is gonna be greater than 0.5. So let's use the 0.55 that we had earlier, right? It was 0.55. Yes. Genius. Okay, so then what we're gonna have is like before, we're gonna have the no, we don't want to do T first. We want to put X first, and X is going to be in P and A range, not a range like I thought it was the one time. Range, A range, and then we're gonna have. We want the segments in there. Yo, can you like move? My cat is cleaning herself and I can hear it. Sorry. So what we want to do next is then we want the temperatures. So then we have to do the NP, and then we also want the the full command thingy that we used last time that kind of puts it in an array, and then we put 300 and then dot because we want it to be that kind of number, and then obviously like 300 was the initial temperature, and then so T, and then we have the brackets, and so we have 0 as being at position 0, right? So on the left side it was 350 Kelvin, and then on the right side which would be just like T, and you have the bracket, and it's just gonna be like, no, that's not a bracket, -1, right? And so is equal to 400 because that's on the right side. And so then let's see, we need to do our big array thing. So I'm just gonna put M because we haven't used that yet. It's equal to MP dot, we need it to be an empty array, and then we need let's see, comma -2, yes, and then M is equal to, no, we're putting stuff inside of it. So then we want the first thing to be, no, we do a comma, then we want it to be like this, I think, right? So the first thing, and so we're gonna basically be comparing it to, let me go up here, to
this right here, I believe. And so you have it's equal to negative r. And then you have yes. And then you have the next one, so comma. And then you want that to be equal to the 1, and it's plus 2r on that side of the equation. 2r, oh, haha, that's not a plus 2r. And so then your next thing, so I did m for matrices, so your next position, comma, and then you want, ew, I don't want a space there, it's inconsistent. And so then the next one is also minus r, because that's the next portion of the side of the equation, right? Okay, so then we're like, okay, well, now we want the other matrix thingy. So let's call it R, because it's on the right side. R is equal to, and then mp dot empty, and then I think it's use nx still, right? That's what I did last time. 3, yeah, you want 3 x, and then minus 2. Okay, so then after that you're gonna do, okay, so r is equal to, and then you have let's go back to here. R times, you have a temperature, and then you have this at position 2, right? Because it's going to be, okay, so the position in the future, kind of. Not the position. But, okay, you know what? Maybe I'll just restart this video. Maybe not. I feel like I'm doing okay. So let me also check to see if I am recording. So everything looks fine on here. And the sound is coming through, so that's good. So then on the right side of the equation, what else do we have? We have this 1 minus 2r and then tj, right? So then you have 1 minus 2r. Do I need to do 2 times r? Yeah, 2 times r. And then t times, and then, so that's going to be like the initial position, right? So you're just going to have, what is it? Just the position 1, I think. Did I just put a semicolon there? I don't want that. I want colon. Yes. Okay, so then what we're going to have is plus, not equals, plus, and then we have the, still just r to the t, and then it's going to be the position before, so r times, and then it's going to be t, and then position, it would be like minus 2, I guess. So then we are like, okay, well, let's set this first thing up, which would be 0 because it's like Python. So r of 0. Let's see. And you want to add r times, let's see, temperature 0, I think. Am I doing this right? Okay. So you want the initial temperature. So, oh. We want that first part right there to be that, then plus the initial temperature times the r, right? And so then we want r, and then let's see, negative 1 is equal to r times. It's really trippy how it does both of the parentheses and brackets for you. So then we add r times, and then you want t to the -1. Yes, I think that's what we're doing. I don't like how I spaced that out. That's going to irritate me. So then eventually we're going to do, okay, so we want a figure, and then so when we do figures, we make, and then I think underscore subplots. Subplot. And then we want the row to be equal to 1, comma, columns to be equal to 1, like we did before in that last one. And we say figure, and then dot add, and then we want a scatter plot. So we want our x to be equal to x because we have x, and then we comma y to be equal to temperature because we have T there. We want the mode to be lines is equal to, and then we have to put that in the what is it? What is it called when it's text? String? Yes. And then comma name, and we want it to be equal to plot, I guess. I don't know. Okay, so we're done with this part of the code. Okay, now we shall start recording, and we shall go back to collaboratories. Okay, so we're gonna start on the next part of our what is it? Code. So for our next part of the code, we need a for loop. Ahaha. Okay, so we're gonna do I for iterations. And then we want a range of, and so then we're gonna have nt plus 1 instead of just why did I say nt plus 1 instead of just nt like I thought it was this one time, and it didn't do any steps whatsoever, and it kind of disappointed me. Okay, so for our t, we're gonna have 1. Oh wait, no, we wanted to -1. Move backwards. We'll solve underscore banded. Yeah, and then we're going to 1, 1, and then we want, what are our let's see, m and r. M, comma, r. Is that all the parentheses I need? Yes. Okay, so then we say r, because we want the right side of the equation. And so r is equal to, and you have r times t of, let's see, the one in the future. And then you have plus, and then you have the 1 minus r, right? Or 2r. Yeah. 2r. Oh yeah, and you have to multiply that. Or it's gonna scream at you. And then you have this multiplied by the temperature, and then that's gonna be like at -1, because that's where it is. What the heck is going on my screen? Never mind. Okay, so then we have, let's see, plus, no, wrong one. So r times, and then we want the temperature at the 2, is it -2? Yeah, so you go -2, so this is going to be on the other side. Why did I do that? Don't ask me. Okay, so you're going to have, so right side is 0, because it's going to be the first position, and so then r of 0, I didn't mean to do that, plus r times t of 0, and then we're going to do the next one, so it goes backward, is equal to, no, r of 0. -1. I don't know why my brain isn't working right now. R, and then you have -1, and r times, and then t -1. Yes. Okay, so after this, we want an if statement. Oh, actually, the if statement should be in line with that, so because we want it within the for loop. So if, and our iteration, so, percentage. Let's make it this. Okay. Let's see. We want a figure. We want an add, and we want a scatter. Okay, so we have x is equal to x comma y is equal to, I think, t, and then we have mode is equal to, and then lines, and then we have, what is it? Title, I think is the, or no, name. Name is equal to, and I think, what do we name it? Like, shoot, it's like f of, and then I think we put the iterations in there. That's how we get it to show up. Okay. So, oh wait, no, but I still need to put in. I'm scared. What did I do? It's fine. And then we need to show our figure. And then it just has like a 2 parentheses right there. And so let's see if she works. No! Okay, what happened? Oh, 2 times R. Okay, okay, I got worried for a second. And they're really getting me on these little. No, that should be there. Operands could not be brought because they're shapes. Okay. I'm gonna pause and come back. Okay, so I think I found out where I messed up. It was a -1 right there. No, it wasn't. Okay, so we're gonna keep look. Oh, my cat. Okay, she scared me. So 0. We're gonna come back again. So I feel a little silly. Rows. That wasn't it either? Columns? Oh, no. Cancel. Oh. Okay, so that's not very entertaining. Let's see what happens when we load the other one. Cleo, have you discovered yourself? Have you discovered what it means to be a cat? I don't know what to do while it's loading. Boy, oh boy. Maybe I'll go get my cat. Hi, baby. Cleo is now a chemical engineer as well. No, don't run away. Cleo is a chemical engineer.
I apologize. Yay! It worked! It worked, and it worked with an R value that was greater than, I'm going to ignore that, than 0.5. And that is the end